So now we're going to be talking about calculating the electromagnetic waves in an X-ray or in radiation. So we're going to be calculating the frequency and wavelength of electromagnetic radiation. So the equation that we're going to use is the wave speed equation, which is the speed of light, which is c, is equal to the frequency. It's going to be okay, that's about F. It's going to be F times lambda, which is going to be our wavelength. For those of you who forgot what lambda is. So that's going to be our basic equation that we're going to use for figuring out electromagnetic radiation. So I have two problems here. And for those two problems, we're going to be using that one equation, so it's going to be up here. So it's going to be C equals F lambda. Oh, and C is the constant, which is the speed of light, which is 3.00 times 10 to the 8th meters per second. That's going to be our constant, and your speed of light is always going to be that number. So now we have two problems, and one says an X-ray's wavelength is 3.2 nanometers. Using the speed of light in a vacuum, calculate the frequency of the X-ray. So it gives us the wavelength, which is lambda, in nanometers, which is 3.2 nanometers. But we're going to change that, and it's going to be instead 3.2 times 10 to the negative 9 meters, because we need to be in meters, because wavelength is always in meters. And then it gives us, or we have our speed of light, which is 3.00 times 10 to the 8th meters per second. And we're trying to find the frequency, and frequency is always going to be measured in hertz. So F equals something hertz. So now if we plug it all in, so it's 3.00 times 10 to the 8th meters per second is equal to 3.2, I'm just going to do E now, negative 9 meters, and we're trying to find the frequency. So you're just going to divide both sides by 3.2 e to the negative 9. And that's going to give you 9.375 times 10 to the 16th hertz. So this frequency is the frequency of the X-ray in this certain vacuum. So that's one way, that's to solve for frequency. But what if we wanted to solve for wavelength? And it's going to be the same thing, because you have the same formula and all you have to do is divide, but we're just going to do an example anyways, just to make sure that you understand the concept of these wave of speed, or speed of a wave, or wave speed equation. So it says, what is the wavelength of ultraviolet light with a frequency of 9.5 times 10 to the 14 hertz? So ultraviolet light, I'm guessing its speed is going to be 3.00 times 10 to the 8th meters per second, because that is our constant. But if it's not, then we're not doing this right. And then it gives us the frequency, which is 9.5 times 10 to the 14th hertz. And we're trying to find the wavelength, and that's going to be in meters. So we just plug this in. Is equal to 9.5 times 10 to the 14 hertz lambda. And we're going to divide both sides by 9.5 times 10 to the 14. And that's going to give us a wavelength of 3.00 3.16. We're going to call it 3.16 because it goes up too far. So it's going to be 3.16 times 10 to the negative 7 meters. And that's going to be the wavelength of our ultraviolet light with a frequency of 9.5 times 10 to the 14 hertz. And that is how you use the speed of a wave equation, wave speed equation, to find, to calculate the frequency and wavelength of electromagnetic radiation.